In this video, I am going to be showing you how to divide polynomials to find zeros and remainders of polynomial functions. Now, back in 4th grade, you learned about long division, maybe earlier, I do not remember. The way you would do long division is you are looking for when this number is going to be able to, or how much can this number be divided into this number. So in this case, we would do 3 goes into 8, 2 times 3 is 6. So 8 minus 6 is 2, and we bring down the next number. 3 goes into 22 7 times. 7 times 3 is 21. Subtract 1. So the answer in this case would be a 27 with a remainder of 1, or you could say 27, and then the remainder is going to be 1 divided by what we had divided by, what we would divide it into to begin with. You can do the same thing with variables. So in this case, how many times does x go into 6x squared? Well, first, if you think about the coefficients, 1 goes into 6 times, and x goes into x squared 1x times. So if you were to take this number and multiply back, 6x times 1x is 6x squared, because 6 times 1 is 6, and x times x is x squared. So you subtract and you'll get 0. So your answer is going to be 6x. Now, in the same way, you have this division algorithm because there's 2 ways that you can actually write the answer to any type of long division. What the 3 is considered is a divisor. 82 is called the dividend. So for example, if you are given some function divided by a function, the original function is called the dividend. That represents f of x. What you are dividing by is called the divisor. Your answer, in this case 27, is called the quotient, and then again the remainder is 1. Now there's 2 ways to write this. You could write this, and if it was this way, then you would say 82, because that's f of x, equals the divisor, which is 3, times the quotient, which is 27, plus the remainder, which is 1. That is how you could actually write this division problem. If I write it in this form, then again, the dividend, f of x, is 82. You're dividing 82 by the divisor, which is 3, and that is going to equal the quotient, which is 27, plus the remainder, 1, divided by the divisor, 3. Each of these is correct in its own form of how you could actually write the answer to a division problem. The same thing applies to polynomials. So here we go. I am going to divide x cubed plus 2x squared minus x minus 2. We are going to divide that divided by x squared minus 1. So we want to know how many times does x squared minus 1 go into this function. So we could go ahead and say this is f of x, this is d of x. So x squared goes into x cubed how many times? It goes into it once. So I'm going to put the x over here because I want it to line up with the same exponent from the function. Now you're going to multiply this x by everything from the divisor. X times 1, or x times negative 1 is negative x. X times x squared is x cubed. Again, don't forget they need to line up. Now I am subtracting this answer from the original. So when I do that, it actually changes the signs. So this negative becomes a positive, and this turns into a negative. So this turns to a negative. So x cubed minus x squared go away, leaving you 0. You bring down the 2x squared. Negative x and a positive x give me 0, so they cancel. And then I bring down my minus 2. And so we do it again. X squared goes into 2x squared how many times? It goes into it twice, because you got to look at the coefficient front. 1 goes into 2, how many times? It goes into it twice. and then x squared goes into x squared, no times because they're the same exponent. So now we do what we do in long division. 2 times a negative 1 is a negative 2. 2 times x squared is 2x squared. But don't forget, we are subtracting this. So when we do that, when we distribute this negative, it's going to turn this to a positive, and it's going to turn this to a negative. So now that we distribute the negative, I'm going to go ahead and erase the parentheses. Negative 2 and a positive 2 cancel, and 2 and negative 2 also cancel, leaving me a 0 for the remainder. So there's 2 ways you could have written this. You could write it as the function is equal to the divisor times the times the quotient plus the remainder. Or you could say x cubed plus 2x squared minus x minus 2 divided by the divisor is equal to the quotient plus the remainder over the divisor. And then 0 divided by anything is just 0, which goes away. Same thing up here. You don't have to write the plus 0. So either one of these, you could write it as the same thing. They give you the same thing. It just depends on which form you want to use or which form you might see on a test. So let's try another one. Now in this case, this is a little bit different because we have x cubed. We do not have an x squared. We need a placeholder. We also don't have an x, so again, we need a placeholder, and then we have minus 9. And then out here, we just have x squared plus 1. So to solve, how many times does x squared go into x cubed? It goes into it x times. So I'm going to put it over the 0x because I want it to line up with the same exponents. X times 1 is 1x. X times x squared is x cubed. Now we are subtracting this entire thing from the function, so I'm going to change the signs because I'm subtracting everything. X cubed minus x cubed go away. 0x squared is still just 0. And then 0 minus 1x is a negative 1x. And now I'm going to bring down my minus 9. Now, at this point, you would want to say, how many times does x squared go into x? Well, it can't. You can never have a higher exponent go into a lower exponent, which means you're done. So the answer to this function divided by this function, or by this divisor, is going to be x plus the remainder, because you cannot go any further, divided by your divisor. And that will be your answer. Thankfully, you do not have to do long division all the time. So to set up a synthetic division, here is what you do. You're going to take the divisor, set it equal to 0. If you were to take x plus 1 and set it equal to 0, you will get x equals a negative 1. So negative 1 is what goes in the shelf, and then you're going to write the coefficients next to it. So you have 3, negative 4, positive 2, negative 1. So to solve this, the first thing I do is I bring down my first term. It always bring down your first term. And then I multiply. Negative 1 times 3 is negative 3. And add. Negative 4 and negative 3 give me a negative 7. And again, multiply. Negative 1 times negative 7 is a positive 7. And I add. I get a positive 9. And then I multiply again. Negative 1 times 9 is a negative 9. And then I add. Negative 1, negative 9 give me a negative 10. This last number is always your remainder. Always. And now, how to write your answer from there. This represents your constant. This represents the coefficient in front of x. This represents the coefficient in front of x squared. And if you had more numbers, it would be x cubed, x to the 4th, x to the 5th, and so on. But please remember, the first number on the right, the farthest right-hand number, is always your remainder. And then it goes constant x squared. So to find the answer to this, I would say that the answer to this function divided by x plus 1 is going to be 3x squared minus 7x plus 9. Remember, that's your constant. Then your remainder divided by your divisor, which is x plus 1. And that would be your answer. Now, note here the difference between synthetic and long division. If you have a linear term, meaning your exponent is 1 of the variable, this is a linear expression because the exponent is a 1 up here. You can do synthetic division. The reason we could not do synthetic division here is because it had an exponent as in the divisor. If the exponent is anything other than 1, you will have to use long division. But if you have a linear expression, then you can always use synthetic division. So for example, I can use synthetic division here. What I first do is take the divisor, set it equal to 0. So I will get x equals 1/2 because I add 1 and divide by 2. That number, 1/2, is what's going to go on the shelf. And then my coefficients will go, oh, wait, there's no x squared. It goes x to the 4th, x cubed. There is no x squared. You got to put a placeholder. And then you have your x coefficient and then your constant. Now you're going to draw a line. Always bring down your first term. Multiply. 1/2 times 2 is 1. And then add. -1 and 1 give you 0. 1/2 times 0 is 0. Add. You get 0. 1/2 times 0 is 0. Again, you add. 2 plus 0 is 2. And then 1/2 times 2 is 1. Add. -1 and 1 give you 0. Again, the farthest number that you end with is always your remainder. And then from there, the next number is going to be your constant. And then the next numbers after that is going to be your coefficient with x, your coefficient with x squared, your coefficient with x cubed, and it's going to continue to grow from there. So the answer to this problem to solve, it is going to be 2x cubed. There is no x squared, there is no x because there are zeros, and then you have a constant of 2, and you don't have a remainder either, so you are finished. There is a theorem called the remainder theorem that basically says if I want to know if a expression is a factor of a function, then I am looking for a remainder of 0. So I'm going to take my x minus 3, set it equal to 0, therefore x equals 3. So I'm going to plug that into my shelf. I have 1, -7, 15, -9. So if I was to solve this using synthetic division, bring down my 1, and I'm going to multiply, add, multiply, add, multiply, add. Because my remainder is 0, therefore your answer is going to be yes, x minus 3 is a factor of that function. The second part of the remainder theorem also basically states that if I plug 4 into this function, what is going to be my y value? Well, you actually can use synthetic division. If I plug, I'm actually plugging in the number 4. I'm not plugging in x minus 4. I'm not saying x plus 4. I'm actually plugging in the number 4. So whatever this number is, it actually goes on the shelf. Don't take the opposite sign. It actually is that number. Now, I'm going to do the coefficients. X to the 4th has a coefficient of 1. There is no x cubed. -5 is the coefficient of x squared. 4, 12. Draw my line. Bring down my first number, multiply. Bring down my second number, multiply. I'm sorry, not bring it down. Add 0 and 40, and then I'll get 4. 4 times 4 is 16. Add these, I get 11. 4 times 11 is 44. 44 and 4 give me 48. 4 times 48 give me 4 times 48 give me 192, and then 192 and 12 will give me 214. No, it won't. Oh, dang it. 44 and 4 will give me 48. 48 times 4 will give me 192. And 12 and 192 will give me 204. So therefore, P of 4, if I plug 4 into this equation, I will get 204. The other way to do that is to literally plug 4 into x. 4 to the 4th power minus 4 times 4 squared plus 4 times 4 plus 12 will also give me 204. So there's now 2 ways to be able to find a value. You can either use synthetic division or you can plug that number into all of your x values. So recap. If I was to divide these, I would have to use long division because I have an exponent. So to do that, I'm going to do x cubed minus 1 goes into x to the 4th plus 4x cubed. There is no x squared, so I need to put a placeholder, minus x minus 4. X cubed goes into x to the 4th one time, or I'm sorry, x times, because x times x cubed gave me x to the 4th. So x times negative 1 is a negative x times x cubed is an x to the 4th. So when I subtract, I'm actually going to change the sign. So that's going to be a negative, and that's going to turn positive. They cancel. I'm going to bring down my 4x cubed. I'm not going to bring down a 0. Negative x and x also cancel, and I'm going to bring down my minus 4. Now, x cubed goes into 4x cubed 4 times. 4 times negative 1 is a negative 4. 4 times x cubed is a 4x cubed. Now, I need to change the signs because I'm subtracting. So that's going to become a negative. That's going to turn to a positive. And those cancel, leaving me a remainder of 0, which means my answer is going to be x plus 4. Next, is x plus 3 a factor? So what I do is I'm first going to set it equal to 0, and I will get x equals a negative 3. That number is what is going to go in my shelf, and I'm going to write the coefficients. I bring down my 1, and I multiply, and then I add, I multiply, I add, I multiply, and then add. Since I got a remainder of 0, the answer is yes.